So now that we're familiar with scale, it's time to look at projection. A projection is basically the method employed to transfer all the features of the Earth onto a flat piece of paper, or a flat computer monitor in our case. This is not a simple task. After all, the Earth is a three-dimensional object and paper is a two-dimensional plane. There are many different methods that people have come up with over the years in an effort to make the most accurate maps, and it is these different projections that are responsible for the many different maps representing the same Earth. It's also the reason that the two maps we saw earlier look different even though they're constructed using the exact same data, that data being the location of all the state boundaries. To understand why we use the term projection, imagine that you have a model of the Earth made of glass, like this one, and you somehow put a light in the center. Turning on the light illuminates the globe, and the land casts shadows on the wall. You have projected the features of the globe onto the wall. That projection is a specific type known as a planar projection, since the surface being projected onto is a plane. Now, let's imagine that you take the same globe and the same light inside of it, and then you take a piece of paper and you fold it into a tube and you place it around the globe. Then you turn on the light, and you're going to project the features onto the inside of the paper tube. If you then unfolded the paper again, you'd have a map of the Earth using what's known as a cylindrical projection. Or you could take the same globe and the same light and the same piece of paper, but this time you fold the paper into a cone and place it above the Earth like a party hat. When you turn the light on, you project the features into it, and then you open the paper again, and you have a map in what's known as a conic projection. In reality, projections are usually created mathematically, and there are infinite different projections possible. Every projection results in some features of the map being distorted. It's just an unavoidable fact of converting the surface of a curved Earth to a flat map, but it can have a very large impact on how we see the world. For example, this is a commonly seen map of the world in what's known as a Mercator projection. While you may not know it, this map suffers from very large distortion. Here we have Greenland in blue and Australia down here in orange. By looking at this map, you'd assume that the two countries are approximately the same size, with Greenland maybe even being a little bit bigger. So, it may surprise you to learn that Australia is actually more than 3 times the size of Greenland. So, if this map suffers from such distortion, why do we use it? Well, the Mercator projection has several features that make it ideal as a navigational tool for seafarers, for whom the projection was originally created. Also, the majority of the distortion is limited to the very northern and southern latitudes, those areas near the poles, and so the majority of the landmass really isn't affected. When determining which projection to use, there are a few things that you'll need to consider. The extent of your map, that is, what is the geographic area that your map is going to depict, the scale of the map, which we've already talked about, and the accuracy of the map. You can use any projection you like on any extent and scale. However, the accuracy of the map is going to differ depending on the projection. If you just want a vague idea of what's out there, then by all means use any projection you like. But if you need a map that more accurately depicts the features on it and the relative size, you're going to want to be a bit more careful in your projection selection.